1, 2, 3, let's go!
This experiment aims about phytochemical analysis of papaya leaf extract, also identify and quantify metabolites in it by liquid extraction. In GC, we inject sample which may gas or liquid into gaseous mobile phase or carry gas. Then, mobile phase carries it to a column that separates its component based via graphing rail to partition between mobile phase and stationary phase. Next, elution order in gas-liquid chromatography depends on boiling point of the solids and interaction between solids and stationary phase. As like if mixture component have significant different boiling point, then choice of the stationary phase less critical. But if two solids has similar boiling point, then separation possible if stationary phase interact with one between of the two. Generate non-polar solids separates more easy when use non-polar stationary phase, and for the reverse, same goes. Our main component in GC are injector, which functionally mean for injecting the samples into GC, then column which functionally where the analyte get separate into individual component depend its affinity with stationary phase and mobile phase, and lastly, detector where the composition and concentration of the analyte are determined.
Sample preparation. Firstly, 10 grams of plant material was ground to a fine powder and extracted with 200 ml of 70% equals methanol, acidified to pH 2 with a few drops of concentrated HCl in a saucelet apparatus for 24 hours at a temperature of 90 degrees Celsius. Secondly, liquid extraction of free phenolic compound was performed on a sample of the filtered extract. The obtained aqueous solution was extracted 3 times with 30 ml of diethyl ether in a separatory funnel after methanol evaporation in a rotary evaporator, and the organic solutions were mixed and evaporated to dryness. BSTFE plus TMCS 1% or anhydrous pyridine were added to the dry extracts. The mixture was heated for 1 hour at 90 degrees Celsius, and a standard solution were prepared at various concentrations. The derivative sample was sent for GC analysis. 3 ml of each standard solution was injected into a capillary column for GCMS analysis. The objective of the derivatization is to obtain the alkyl silylated derivatives.
Okay, now we're going to operating condition. A VG4 spectrometer with a Supelco SPP5 capillary column was used for the gas chromatographic and mass spectrometry analysis. The column head pressure of the helium carrier gas was set to 100 pressure. The inlet temperature was set at 280 Celsius. Meanwhile, the oven temperature was initially set to 100 Celsius for 3 minutes, and then it will increase to 350 Celsius after 20 minutes. With an ionization energy of 70 electrovolts, the mass spectrometer was operated in positive electron impact mode. At a pressure of 10 E photon, the ion source's temperature was 190 Celsius. The selected ion monitoring SIM mode was used to detect peaks, which were then identified and quantitated using target ion. The identification of each peak was achieved by comparing the retention time and mass spectra of the compound in the extracts.
Based on the total ions chromatogram TIC, all the 5 compounds are known as phenolic compound, following by the result data of retention time RT and mass to charge ratio M/Z for each ion and table content. In this table, the RT obtained in GCMS system used in this work and the M/Z ratio characteristic for each ion of all the analyzed standards are shown. Next, peak identification was obtained by GCMS analysis. This analysis of papaya extract detected molecular peaks with typical RT of analyzed standards. As you can see, peak number 2, RT1102 mean, correspond to proteic acid, while others are referred into the table by peak number 3, 4, and 5. While peak number 1, RT10.81 mean, it corresponds to a compound with MS equal to peak 2, which is p-coumaric acid, but with different RT. Probably the peak represent an isomer of the phenolic acid such as M-coumaric acid or O-coumaric acid. Meanwhile, the other components of sample were detected at particular value as shown in table 1 in the journal use. In this work, caffeic acid is the most abundant of all the identified compounds compared to other compounds. Last but not least, the advantages and disadvantages. First, it enhances sample identification with higher sensitivity, the quantitation will highly accurate, and give the fast result, and this is also with increased range of analysis. While for limitation, these methods are limited to thermally stable. As an example, we are using GCMS for drug confirmation testing or broad spectrum drug screening. GCMS methods are not capable of directly analyzing drug because drugs are non-volatile, polar, and also thermally labile. Most GC detectors also are destructive except for MS.
In a nutshell, Carica papaya leaf extract were analyzed using glass chromatographic and mass spectrometry in SIM, which is selective ion monitoring mode. The area ratios of the sensitive ion were matched with those of corresponding standard, allowing each peak to be identified by comparing the retention time and mass spectra of the compound in the extract to those of the standard.